Now we are taking a very simple example for the implementation of deep learning. We are taking a handwritten digit. Even though now we are not using the convolutional neural network initially, the example which we are taking now can take to the deep learning aspects. So now in the first line of this code, you can observe there is an import TensorFlow as TF. In the Python, whenever we want to call a function in another file, we will, if we have the provision to write the code in two files, because if we feel the length of the code is high and we have splitted, we have written some functions in one file and we have written some other functions in another file. If we want to call the functions in one file by using by using this import, we can call the functions in another file to the existing file. We will look into an example. So you can observe here, I have taken a Py file test1.py. Here I am defining two functions. For defining functions, I am using def. The name of the function is function1. I am using parenthesis. This is how we define a function in the Python. And then what is the particular task I am thinking that function has to do when I call this function? The particular or special task that the function performs is it prints this is function 1. Whenever we call this function 1, how many times we call this function 1? Every time this function 1 will print this is function 1. Similarly, when we call the function 2, it will print this is function 2. Okay, these are the two functions I have taken in a file test1, but in real time, we may have thousands of functions in single file. In order to make it is simple and it is convenient, I have taken only two functions. Now I have taken another file. I have named that file as test.py. .py extension tells it is a Python file. Now I am using the command import. Here I am interested to import something. What I am importing? I am importing test1. Here I am interested to import the functions in the file test1. While importing, I have also the provision to import that file with a short name, such that that short name I can use anywhere in this file. So now I am importing that as T1. Now I am calling T1, and when I write T1, you observe here, when I write T1 dot, it is giving two provisions, function 1 and function 2, only two provisions, because I have defined only two functions. Similarly, when you import some function or when you import some library, then when you put that particular example here, T1 dot, that will give all the available functions in that particular file. Now here, I am taking T1 dot, and after typing T1 dot, here function 1 is coming. This circle is indicating that the file is not at all saved. This circle is coming here, you can see. So in order to save the file, you know, the control plus S we have to use, and then I am executing. For executing, you can observe here on the right top portion, you can find the run. So here it is executed. The executed thing you can observe here. This is function 1. This time I am not interested in calling the function 1. This time I am calling function 2. So now I am executing again. You see, this is function 2 is executed. This is what we actually do with the import. So whenever we are using the import, it tells us, I have written some code in another Python file. I don't want to write the code again. I wanted to import the functions of that particular Python file. So I am calling the import, and the file name, whatever may be the file name. If the file name is test1, I have to write as a test1. If the file name is test2, I have to write as a test2. This is how We import a function, a group of functions, many functions, maybe thousands of functions in one file also, or different functions in different files. We can import functions in one file. So we can import libraries which are existing to the our framework or to the existing file where we are working. But what we are importing here in this example, we are importing a TensorFlow, and then we are mentioning a TensorFlow as a TF. What is this TF? This is a shortcut. You can write anything, whatever you like. And from TensorFlow, we are importing Keras. That means from the TensorFlow, this Keras is integrated with the TensorFlow. What is this Keras? Why we are using Keras? We might have had Keras from many who are using the artificial intelligence, who are working with the machine learning topics, who are working with the neural network topics mainly, because Keras is a neural network API. Okay, we will discuss about what is Keras and what is TensorFlow, why we are using them in the initial lines. Okay, in this file you can observe the starting line I am using is import TensorFlow as TF. Just now we have discussed import means we are importing the functions of one file to the existing work. My existing work is this Jupyter notebook file. In this first cell, I am writing the first line code, import. I am importing the functions of one file, the TensorFlow. Here we do not call TensorFlow as a file. Instead of that, we can call it as a library. TensorFlow is actually a API. So in the previous days, the TensorFlow 1, and now we are using the version TensorFlow 2. About that, we will discuss. 2015 TensorFlow in November, the TensorFlow was first introduced. We will discuss what is actually TensorFlow, why we are using. And when we are saying TensorFlow as a TF, it is indicating that we are interested to start the TensorFlow as a TF. And from the TensorFlow, we are importing Keras. That means this Keras is doing some function, and this Keras is integrated in the TensorFlow library. If we have to talk strictly, then TensorFlow is an API. If we have to start strictly, then Keras is also an API. Okay, how the Keras is integrated with the TensorFlow version 2, and what is actually Keras, why we are using Keras. You might heard about the Keras from many persons who are working with the artificial intelligence, mainly deep learning aspects. When they are working with the neural networks, now from the last 1 year, because September 2019, the TensorFlow version 2 integrated with the Keras. Later on, we can observe the many changes happened, and many persons drastically observed the easiness in using code for building a simple layers to a complex convolutional neural network. Now we will learn what is Keras and why we are using what is TensorFlow. What is Keras? Keras is a high-level API that is designed for the neural networks. In ancient days, means in old days, they used to build a network by using many lines of Python code. But after the implementation of the Keras API, neural network API, it is giving the chance to us to build many layers with a single line and a 2-line and a 3-line code we can implement. If you want to implement some max pooling layer in one line, you can do that. If you want to use the dropout layer, you can do that with a single line. So it is a neural network API. And this neural network API, we call this as a high-level API because it is user-friendly. We can use it very easily. It is working with the 3 lower-level APIs. What are those 3 lower-level APIs? One is TensorFlow, one is Theano, one is CNTK. Means before the implementation of Keras, example, the Theano, which was introduced in September 2007, that was introduced by Microsoft. in order to implement the neural network layers in the work, they have their research team did a research on what to implement. Then they have started doing the Theano. They started the Theano. Theano is a low level API, means it is difficult for the user to implement the neural network layer by using this low level Theano. Sorry, CNTK was implemented by Microsoft. Theano was implemented by some university. CNTK was implemented by a small correction. CNTK was introduced by Microsoft. It is called as toolkit. CNTK was introduced, and Theano was introduced previously, and Theano was very much famous and very much popular until now. Even today, many persons are using Theano. It from 2017, the Theano stopped giving the updates. It says that Theano was dead as of now, but still many persons have spent majority of their life working with the Theano. That's why they are unable to switch suddenly to the TensorFlow. But we have to accept the original scenario. TensorFlow became popular, even though TensorFlow was introduced in 2015 by Google Brain team. So it became very much popular. At that time, the TensorFlow was not integrated with the Keras. So it is like Keras is the front end. We are using the Keras for the application. And the back end, either you can use TensorFlow, or you can use the Theano, or you can use the CNTK. So any one of these three low-level APIs you can use as backend, and you can use Keras as a front end because Keras is user friendly. You can write the code easily. By using the Keras, you can build the layers easily. And later, the Theano and CNTK, these two low-level APIs, they became little bit difficult for the users. They became the TensorFlow. It became very user-friendly at the back end to implement the Keras, and all started using TensorFlow and Keras. By understanding this, Google in 2019 September, they have integrated the Keras in the TensorFlow. This version they called, the previous version they called TensorFlow 1. In that, the Keras was not integrated. After they have understood the users, they are started using TensorFlow and the Keras. They wanted to make it more popular. Then in 2019, they introduced TensorFlow 2. This is revolutionary, because from 2019 September, the entire coding aspects of the deep learning, the entire way to execute the things completely changed. That's why if you refer the previous papers, they still either many of the others were working either with the Theano, or many of them working with the TensorFlow 1 model where the Keras was not integrated. You cannot find the Keras. But now from the September 2019 until now, only still it is not 2 years over, the TensorFlow 2 came. In this TensorFlow 2, Keras are integrated. Because the Keras library is integrated, if you install TensorFlow in your system, that is sufficient, because already in the TensorFlow library, Keras is there. Previously, we have to install TensorFlow and Keras separately in the version 1. But now in the version 2, there is no need to install the Keras separately. If we install the TensorFlow, from that we can import the Keras directly. As we discussed what is CNTK, CNTK is nothing but Microsoft Cognitive Toolkit. It is previously known as CNTK, and Microsoft developed it for their internal research, and later they have released it for the users also to work on it. Before TensorFlow, even many persons, because TensorFlow was introduced in 2015, many persons worked with CNTK also. Theano, as I mentioned, it was old, and it was developed by University of Montreal, I think, if my pronunciation is correct. And from 2017 September, it became dead. But still, many of the persons who are in the field of artificial intelligence, because their scope of understanding Theano, they became very much familiar with it. They are unable to quit it. But still, we have to understand the original scenario of the evolution. We have to accept Theano and CNTK are no more we can use as of now for the existing deep learning problems. So now it is advisable to use the TensorFlow, which is integrated with the Keras. Now we will discuss about differences in the imports. We discussed what is import, and later we discussed we are importing TensorFlow, and we discussed what is TensorFlow and version 1 and version 2, and we discussed the Keras, a integrated package in version 2. Now we are discussing how previously we used to import Keras. If we want to import, we used this command like from keras.layer import dense when Keras was not integrated with the TensorFlow. This was the code they used for the version 1 TensorFlow. Now we have the provision to use TensorFlow.keras.layers. This is indicating that you are using the TensorFlow version 2, which is also indicating that Keras is a built-in package with that TensorFlow. Now, if you want to import dense layer, you can tell from TensorFlow.keras.layers import dense. And why we are using this from, we will discuss about this. If you are familiar with the Python coding, I hope as of now you have understood why we are using from, but for the persons who does not know, we will explain it. As I mentioned previously, when we use import test1 as a T1, we are importing the functions of the file test1 to the existing file. Now in the Python, when we give the hash, then that line will not be executed. That line will not be treated as a command. So when I use from test1 import star, this is giving the chance to import all the functions simultaneously. At that time, there is no need to use even T1 dot also. I can execute directly function 2. Now I am executing. You can observe the output. This is function 2. This is what executed. Again, we are discussing the fundamental aspect. When I write from, we are saying, okay, from test1 import. When I say star, you import all the function. I am not interested in naming in any function. You import all the functions in that file. Then because we have imported all the functions in that particular file, there is no need to mention again T1. Directly we can give function 2. This is the advantage. If we mention from test1 import star, if you are interested in only importing function 1, that can also be done. Example, I am importing function 1. Now also there is no need to mention T1 dot function 1. I am executing this one. You can observe. So this is function 1. You try to understand the basic difference between when I am using the from test1 import and when I am directly using the import. Now this time I am disabling the from test1 import. I am directly using the import test1 as T1. At this time, we cannot execute this one. This will show error. That's why you can observe the red color mark is coming. Now we have to use T1 dot function 1. Then only when we are executing, it will give the function 1. This is a small fundamental thing in the Python. I hope you learned in the Python. Those who have not learned, now I hope you all understood. Okay, we have imported TensorFlow and we have mentioned as TF. And from TensorFlow, in the TensorFlow, we have many functions. You can think we have imported Keras and we have discussed how we are doing that with a simple code. If you want to import all, you can mention from TensorFlow import star, or if you are mentioning a particular file and mentioning from test1 import star means you are importing all functions. Okay, as of now, I hope the first 2 lines are clear to you. And we discussed what is TensorFlow. TensorFlow is a backend we are using. You do not directly work with the TensorFlow. It is a low-level API, particularly designed for the neural networks. It was developed by Google in 2015 version 1. Still now we are using version 2. In my in my Jupyter notebook, I am using the Google TensorFlow version 2. And later we discussed Keras. Keras is the high-level API which we are using as a front end. Okay. In the next line, you can observe import matplotlib.pyplat. This matplotlib.pyplat we generally use for the graphics. It is like MATLAB only for plotting. So whenever you want to plot some results, whenever you want to plot with how many epochs, what is the training error, what is the validation error. If you want to see the results in every project, results are necessary for us. If you want to see those results in the graphical form, then matplotlib is useful to us. So this matplotlib.pyplot, we are importing this matplotlib.pyplot and we are importing it as a PLT. So next time onwards, when I want to use the matplotlib.pyplot, in that if I want to use any particular function, I can use PLT dot. Okay, next, NumPy. These two are commonly used modules. One is matplotlib and the second one is NumPy. When we are using the NumPy, we can handle the arrays and we can even handle the matrices also. So now we are importing the module NumPy as NP. Okay. If I write from NumPy import star, means this NP also not required. You can observe a line here that is written, Keras is a neural network API written in Python. This is written in Python and it is integrated with the TensorFlow only in the version 2, not with the version 1. Okay, I think first cell, you are familiar with the first cell. Now I am executing. In order to execute the cell in the Jupyter notebook, we have to use the shift plus enter. I have used the shift plus enter. Now it is executed. How I know it is executed? You can observe the kernel here. If the kernel is busy, still it is not executed. And at that time, you will find star here. If it is star coming here, that means that cell is not at all executed. Now we require a data set. What is our problem? Handwritten digit. So we require a handwritten digits data. Handwritten digit means it is handwritten digit 1, it is handwritten digit 2, it is handwritten digit 3. So we are taking the data from the Keras because we have imported the Keras. In the Keras also data set is available. I am now giving the link here. We can go to that link. I'm simply copying that link. These are the different data sets available in Keras. This is the data set we are using now. And CIFAR10, CIFAR100, different data sets are there. Now I am using the basic data set, MNIST data set. Okay. What are there in this data set? They are telling, if you want to import this data set, you can use this command. And they are mentioning at the time of using this particular data set, you should have two types of tuple. Tuple means it is a data type in the Python. We have different data types. One is called list and another is called tuple, and we have dictionary. That data types list and tuple, they almost works similar. They almost work in similar fashion. The only thing is we cannot delete the elements in the tuple once we add, but we can delete the elements in list. And we cannot append the elements in the tuple. Once you assign the training set, you cannot add again single image to the training set in the tuple, but we can do that to the list. The appending and the deletion, modification operations are not possible with the tuple. How we know whether we are using a tuple data type or list data type? When you are using tuple data type, you mention it by using these braces. We will call these as open braces. When we are using a list, then we use the square braces. This is how, by seeing the braces, we have to differentiate whether the data type we are taking is a tuple data type or it is a list data type. It is like, for the persons who do not know the Python, it is like the data types we are taking integer, and char and float in the C programming. When we take a structure is a group of heterogeneous data types. Similarly, list also we can think it is a group of heterogeneous data types, but we should not call it as a structure in the Python. We have to call it as a list. Okay. Similarly, tuple also, there is no need that in the tuple only integers we have to take. We can take an integer, character, or float, any value. But all these are grouped together and we are calling that type of data type as a tuple. We have to create two tuple data types. One is for the training and one is for the testing. And this is one tuple variable, xtrain, ytrain, xtest, ytest. Now we are taking them as an array. This is one array. The first one is one array. The second one is one array. How many number of images are there in this data set? For the training, 60,000 images are there. And the size of each image is 20 by 28, a very low resolution image. And in images, what are their numbers? 0 to 9 numbers are there. And what is this test? In the test, we are taking 10,000 images. And each image size is 28 by 28. Okay. Now you have understood what is xtrain. In the xtrain, we have 60,000 images. Now you understood what is ytrain. In the ytrain, we are having 60,000 values, because xtrain is nothing but the image we are giving. Example, this is 2. Ytrain, it will give the value corresponding to that image. Combinedly, we call this as a training example, xtrain and ytrain. In the xtrain, if we take a number, example 4, this is the handwritten digit 4. But in the ytrain, we may get the equivalent value as a computer 4. Now you have understood. In the xtest, we have 10,000 images. And in the ytest, we have the corresponding values. We train our network by using xtrain and ytrain. And we will ask the network to predict the values for the 10,000 images. How we train our network by using the xtrain? Now we will discuss. What is an image? I am taking a 28 by 28 image. In this image, there might be a number 2, example. I want to recognize that number. What is this image actually? We are taking this image is nothing but a group of pixels. Whenever we take an image at any point of time, example, we have captured an image with the mobile. This is the area. In this area, we have captured the image with 1 pixel camera, means the resolution is less. We are capturing the optical information and equivalent electrical information of that picture is stored in the digital camera. Now, how the digital camera can store that information? Definitely, it cannot store the colors, but it can store the equivalent information for the colors in the range of numbers. In the range of binary digits, you can think for each pixel, we can have the value 0 to 255. Example, in the computer, we are storing that image as 0 to 255. That is 1 pixel image information. Why we are storing 0 to 255? Because the computer can understand only the binary numbers. How it understands only binary numbers? How the computer knows whether it is 0 or 1? This is the binary 255. 255 does not mean it is decimal 255. It is binary 7 ones and last one is 0. This is the, I think all ones, 3, 6, 7, 8 ones. Then it is 255. Okay. How the computer recognizes whether it is 1 or 0? Computer does not know what is 1 and what is 0. But the processor in the computer, it is made up of our semiconductor transistors. They can handle the high and low electric pulses. Whenever we are sending a low electric pulse, it will treat as one class. Whenever we are giving high electric pulse, it will treat as another class, 0 and 1. That's why we are saying it is capable of storing the binary information. So when we give the image, the computer is storing the number only, that is electrical voltage only if we speak strictly. When we are giving the audio, still it is storing the numbers only or binary numbers only. If we talk in depth, it is storing only the electrical information only. When we are giving any text, any document, still the computer can understand with the language of numbers only. When we type something, still the computer can understand with the language of number. Number does not mean literally number. Computer does not know what is 0 and what is 1. It only knows and it only understands, it only can process it, it can only store the equivalent electrical information that is related to 0 and 1, which is nothing but low electric pulse and high electric pulse. Now that is the real sense of an image. When we captured an image with our camera, and I assume that camera is having the capability to store the digital image, that digital image nothing but you have taken an image. If I am taking a grayscale image, the value is in between 0 to 255. It is indicating how much color is varying from 0 to 255. Later, when I have considered it as a 2 pixels, means the same spatial area I am taking, I am not incrementing the spatial area, but I am interested with my camera. My camera is having the capability to capture the information in 2 pixels. Now I can represent here one number which is ranging between 0 to 255 in the first pixel, and in the second pixel I can have another number. Like that, if we take the 1 megapixel camera example, 10 to the power 6 pixels we are taking, means 10 to the power 6 binary values, 10 to the power 6 values which are ranging in between 0 to 255. That is what the computer is actually storing. So if I want to process a handwritten digit image, I do not know what is that image, only I have to process these numbers. So in my case, they have clearly mentioned my image size is 28 by 28 pixels. As I mentioned, in each pixel, we can have the value in between 0 to 255 if it is a grayscale image. If it is a colored image, in each pixel we have R value in between 0 to 255, G value in between 0 to 255, and a blue value. Because any color we can represent by using these primary colors. Now, how many images we have in the training data set? 60,000 images. The computer does not know what are these 60,000 images. Computer is saying I have 60,000 different arrays. In each array, there are values, so 28 by 28 values. In each pixel, we have example 0 to 255. So how many pixels are these? 28 by 28 pixels. These many pixels we are giving. These many pixels we are giving as an information to input, and we will train. And after training, finally, the neural network has to predict it as a 2. So this is our input, X input. And this is our output, Y output. This combination is called as a training example. Now we have trained the neural network with one image. We are telling to the neural network, there is no need to worry. I have given an image. I will tell what is there in that image. What is there in that image? 2 is there in that image. Then the neural network asks, you have given only one image, still give some more images. Don't worry. I have 60,000 images. And I will tell what are the values in those 60,000 images. I will tell the values. The values are Y and the images are X. Then we are calling the neural network is a trained. And later we are asking to the neural network, are you ready? Now I am ready. And now I am trying to check you. Now I am giving an image. Now tell what is the value in that. If the neural network tells properly, we will tell we got the result. If the neural network is not giving the result, then we say there is an error. We want to calculate the error. In order to calculate the error at the time of its prediction, Y prediction, we are checking with the values, original Y test values. If the values of prediction and test values are matching, then 100% accuracy, 100% result. If there is an error, only 1, 2 images it is not able to identify, some 98% error, like that. So we are giving YT. In the data set we have YT, but still we are not giving this YT to train. We are intentionally keeping to the end in order to make what the error is between the predicted value and test value. This is what we are going to do. Okay, we have discussed, we are taking the images, and I have clearly explained where I am getting the images. I have mentioned Keras. I have given even the website description also. Data set is available. I am taking the data set. After loading the data set, we should be capable of handling the data set, because they have mentioned 2 tuple arrays are required. I have taken 2 tuple arrays. First tuple array, xtrain and ytrain. Second tuple array, xtest and ytest. And I have mentioned some values, but still you are asking what is the guarantee that in the xtrain there are 60,000 images. Now we are checking what is length of xtrain. Length of xtrain indicates 60,000. So it is saying we have 60,000 images in xtrain. But remember, just now we have discussed those 60,000 images are not stored in xtrain as 60,000 images. Those images, when we have captured, then only they have stored, they are in the form of the binary numbers, you can think. So those binary numbers, those binary 60 in each image, we have 28 by 28 pixels. So in each xtrain sample, we have 28 by 28 array. Now xtest, as we mentioned, 10,000 images are there in xtest, and we are checking what is the shape of xtrain 0. Xtrain 0 indicates that it is an index. What is the first image shape? First image shape is 28 by 28. I can also check what is the second image shape. Second image shape is still 28 by 28. I can check still 59,999. Now you can check it is 28 by 28. But if I want to give the 60,000 number, it will show the error, because 60,000 means we have started indexing from 0. Now it will become 60,001. Now it has to show the error. See, index error. The error also, if we read properly, what is the error? It is coming index. Index 60,000 is out of bound. So there it is saying, I do not know what is the 60,000, because from the 0 we have started until the 59,999 we can give. And in order to find the shape in the Python, we use xtrain.shape, and the shape is 28 by 28. This is low resolution image. Okay. And until now I am saying theoretically, actually it is not an image, it is values, it is values, it is values. I am saying again and again and again, because in order to make it clear that we are giving values. But now you wanted to know, okay, if they are values, let me show those values. Now I am printing the values of xtrain of 0, which is nothing but it is an array 28 by 28 array. This is first 28. This is second 28. This is third 28. This is fourth 28. Means in the first column, these are the values. These are the different rows, pixel values. These are the pixels of first column, second column pixels, third column pixels, fourth column pixels, fifth column pixels. Means until the fifth column, there is no information. Next, sixth column pixels, there is an information. That information is mentioned in 18, 126, 136, 175. It should not crash 255. That's what we have discussed. This is our image, but we are discussing that image with the help of the numbers. Now, how many arrays we have like that? We have the arrays 28. Each array is having 28 values. Means if we think each array as a column, then in each column we are having 28 values. Means each array is having 28 values. Means in each column we have 28 rows. Now if you say, okay, it is fine, you have taken only first image, maybe second image is having different size. Okay, say take second image. This is the second image. In the second image, the values, see, those are different. This is indicating that even sometimes we may get the point values also. There is no guarantee that every time it has to be an integer. but the value should lie in between the 0 and 255. You have to remember that. Now I am giving some 59,999. Why I am typing this last number is in order to make it sure that until 59,999 only we have the images. Now these are the images of 59,999. So I have printed. Now you have understood what is an image real time, which you can use for your applications. Again, I am changing it to 0. And now you want to see the visually, you want to see the image. These are values, but human being is not able to tell what is the number by using the values, but computer is able to tell. This is like the encoded version, which you are using. The Prabhu is using the encoder and decoder. In that concept, after encoder, we are unable to read what is actually there. This is encoded version. You can think in that manner. Then we want to see what is this image. At that time, we are using the matplotlib and we are saying plot dot, because we have used matplotlib dot pyplot as PLT. That's why PLT is sufficient. PLT.mat. So show me the first image. The first image is 5. For the image 5, these are the numbers. Now you have understood a little basics, even if you do not understand Python. If you want to get the second image, then simply change the index to 1. Then it is 0. If you want to get the 11th image, then change the index to 10. If I want 59,999, means it is the image of the 60,000. Now I am getting 0. Now I am intentionally giving 60,000 because it has to give me the error. It should not show the image. It is saying again the same error. Sometimes the error tells. From the errors also many times we can learn. Index error means the error is in the index. Oh, then we have to understand. Okay, the error is in the index. I have to change the index from the 60,000. Again, I am changing to 0. Now the value is 5. It is fine. X train. Now we are taking Y train. In the Y train, there is no image. We are telling, hey computer, remember the value of that image is 5. Okay, if you are not satisfied with one, I will give the another image also. This is the image, X train 1 and Y train 1. Now I will execute both. First I am executing the above line. So it has to give 0. Now we will execute the below line. The value is 0. If we take the 59,999, then the image in the image, the number 8 is there. Now we are telling neural network, remember, now you have to predict the 8. So we are giving 59,999. So the value is 8. Now this time we are telling what are the first 5 values, give some first 5 values. Then we are printing those first 5 values as Y train first 5 values 5, 0, 4, 1, 9. In order to see what are the numbers, different numbers you are taking. Now, if you are not satisfied with the first 5 values, you can take first 10 values also, that is fine. These are the first 10 values. If you are not satisfied with the first 10 values to see, you can take even the 20 values also, that is also fine. If you want in between also, you can take, I want a 10 to 20 values, that is fine. You can take 10 to 20 also, that is obvious. So you can take the values from 59,995 to 59,999. That is possible. Those 4 are the values, those 4 values. This is only how we can, if we want, this is 5 we have taken. Okay, and similarly now we have images, Xtrain and Xtest. These are images, but remember, images are stored in an array, in the form of an array, 28 by 28. But values are in the range of 0 to 255. I am not interested in those values because some value may be 255, some value may be 1. I want all the values to be between 0 and 1. Why? The reason is it is easier for our sigmoid function, which we are using here. When we give the values in between 0 to 1, it is easy to handle. It can handle even the larger values also. But at that point of time, the non-linearity which we are getting, it might not be the correct case without scaling, without feature scaling. If we give some features are in different range, some values are in different range, and another value is in different range, like it is telling we are comparing the Indian rupee and American rupee. If we ask what is the cost of, example, we can any object, what is the cost of one pen? If we say this is 5 rupees, and if we ask what is the cost of this pen, if they are saying example $1, then we say okay, 5 rupees is cheaper. We should not think 5 rupees is costlier. We should not think in that manner, because these two features are different. This is in dollars, this is in rupees. That is what, for if the two features are different, we generally use it to scale such that the rupees also should be in between 0 and 1, dollars also should be in between 0 and 1. That is what we call as feature scaling. When you learn the basics of the regression concepts in initial times, you will understand what is the requirement of the feature scaling. Now, if I ask you, how many features are there here in this image? How many features? 28 by 28 features. 28 by 28 features we are taking. We are expecting all the features to be in the same range, that is in between 0 and 1. How can we do that? By dividing that by 255. The greatness with the programming is, if we divide with the 255, it will divide all elements in the array. I am not dividing a single element, I am dividing all elements in that array. Similarly, X test, I am dividing all elements in array. Why I am not dividing the Y? Because Y, in the Y, what image is there? Y is only the value, a single value. So that's why I am taking the X train and I am dividing it with 255. I am taking the X test and dividing it with the 255. Now, after the division of the 255, still you are not guaranteed. You want to see, because as a technical people, we want to see the experiment. We want to see what are the numbers, whether they are in between 0 to 1 or not. Okay, let's execute that one. So we have executed, and now see the numbers are in between 0 and 1. Previously, these numbers are in between 0 and 255. Now these numbers are in between 0 and 1. This is what we call as scaling. We have scaled, and now we are sure. Okay, X train is nothing but an image. Image means now all of you are very much sure that it is a array, two-dimensional array with 28 rows and 28 columns. And each element in this array is in between the range of the 0 and 1. Now we are ready. This is what we call as pre-processing. Until now, just we are checking how to give the data. Until now, there is no concept of the neural network. Just we are checking what is an image. From the fundamental aspects, we have started. These aspects are useful to you in the coming projects also to you. Now, after that, we wanted to flatten. What is this flattening? We are saying, you are saying 28 by 28 image, that is fine. But how can I give this 28 by 28 to the neural network? Then I am saying there is no need to worry. What is 28 multiplied by 28? It is 784. Okay, you take those 784 values. Means we are interested in changing this two-dimensional array to single-dimensional array. That is what we call as flattening. What we are flattening? The 28 by 28, the two-dimensional array in X. How many such arrays are there in X train? 60,000 arrays. We are changing those 60,000 two-dimensional arrays to 60,000 single-dimensional arrays with a single command, dot reshape. We are saying, okay, now we are saying xtrain dot reshape. This is the variable. If we have a, b, dot reshape means we are giving the size. What is the new size? Means example, I have an image, I have an array with some 10 by 28 by 28. Or you can think, I have an array, two-dimensional array. What is the two-dimensional array we have? It is 60,000 by, I am writing with the mouse, so it is taking some time. Okay. It is 60,000 by 28 by 28. This is a two-dimensional array, that is 60,000 images. Now, how we want to reshape? We want to reshape them as 60,000 by 784. This is what we call as reshaping. In the real term, we will call it as a flattening, because 28 by 28 image pixels we have changed into a single dimensional array, that is 784. Now, after the flattening, we are taking the first value, and this time we are checking whether we are getting array, two-dimensional array, single dimensional array. See, this is single dimensional array. All the 28 by 28, 784 values are there in the single array. You remember this. Previously, we have 28 arrays, because that is a two-dimensional array. In each array, we have 28 columns. 28 column arrays, and in each column array we have 28 rows. But now in one training sample, when we take the X train, the flattened X train, we have 784 values for the single training example. This is what we call flattened. In order to make it simple, we have taken a image here. In the Jupyter notebook, how we can insert image? You can go to anywhere in the Google, you can copy that image, and if you copy that code here, simply that image will be copied. Okay. In order to make it sure, I will show the code I have copied. This is the code I have copied. After copying that code, if I execute that one, you can see that image. Sometimes images in the image, by seeing the images, we can get the information very much easily. That's why I have taken an image. I'm explaining the entire process again. We have taken an image too. This is an electrical equivalent image for the optical information. Means I have to represent this with some pixels, 28 by 28. Now this is 28 by 28. For the time being, you can think this is a 28 by 28, 28 rows and 28 columns. In each pixel, we have the values in between 0 and 255. Now I have flattened. Flattened means only a single column vector, 784 values. This is for one training example. How many like this we have training example? We have 60,000 training examples. Now what we will do? We will assign each value to one neuron. Means because we have 784 values, we should consider 784 neurons in the first layer. If I would have taken the 50 by 50 image, then you should consider 2500 neurons in the first layer. If I would have considered 30 by 30 image, then you should consider 900 neurons in the first layer. So the number of neurons in the first layer, when we are taking a basic neural network, that is decided by the size of that image. So now we have 784 neurons. The first input layer size is being determined by the size of that image. What is the size of that image? Based on that, if the size of image is 50 by 50, you will get 2500 neurons. If the size of image is 30 by 30, you will get 900 neurons in the first input layer. And then initially I will explain without any hidden layer. I am directly taking the final layer. In order to make it is very simple. Means this problem is handwritten digit classification. I should have 10 neurons at the output. Each neuron, whatever I am taking these 10 neurons, each neuron is classifying, each neuron is capable of handling the data. First neuron is capable of handling the data that is related to 0. Next is 1, 2, 3, 4, and so on, 9. How it can predict whether the given number is 0 or 9? Based on the value. The value 0.92 is the highest value out of all the 9 numbers. So it predicts the number as 2. That's how we are doing. In order to get the numbers like this, we have to use the crash entropy, sparse categorical crash entropy. Sparse categorical crash entropy, when we are using, if you count the all numbers, if you count the all values, the value should be definitely that should be equal to 1. Okay, what we are doing in this neuron? We are simply assigning the weight here to each and every wire that is going from the input to the final neuron. Now, how many wires we have like this? The number of wires depends on, example, here we have 784 neurons. How many neurons we have in the final layer? We have 10 neurons, 0 to 9. So how many weights we have? For each neuron in the final layer, we have weights from the 784. So 10 into 784. We have to calculate these 7,840 weights. Actually, what is our neural network is doing? It is only assigning values to W1 and W2, like that 7,840 weights are there. When we are giving each image with the increment of the number of images, it is changing the weights every time. We call in the real time that as an experience. The situations which we handle in the real time changes every time. The same situation which we handled as a child, we don't afraid about the same situation now, because we handled it many times. First time when we are writing the examination, maybe in the 10th class, the how we appeared, that might not be the same scenario how we are preparing for the final examinations in the engineering or in MTech. Situation may be the same, and even the syllabus is more, and even the handling capability now that became more. That's what we are calling as an experience. By training with the each image, these weights, 7,840 weights are changing. Okay. Remember, in this neural network, I have not considered any hidden layer intentionally in order to make it very simple, a simple neural network with no hidden layer. Now we will try to execute this. As I mentioned, this TensorFlow version 2 is capable of handling Keras. Directly, I am taking the Keras. Keras.sequential. I have taken a variable model. You can take any variable, A, B, C, D. That is a variable. But Keras.sequential, why I am using the sequential? Sequential means we are taking a stack of layers. And remember, when we are using Keras.sequential, it accepts each layer as a single element. Means we have two layers now. First layer and last layer. These two layers are accepted as two elements. That's why we are taking it as a sequential. Two elements means it is handling the data of the two layers as two elements. That is fine. But how I have to write the code? Keras dot layers dot dense. Directly I have gone to the dense because this is the dense connection. Dense, what is dense? Why I am calling as a dense? Dense means if you are connecting all neurons to the next layer, then it is called as a dense connection. See how much dense it is. Means each wire from the 784 neurons is going to first neuron. Each wire from the 784 neurons is going for the 10th neuron also. This type of connection is called as a dense connection. Now here we are giving the input. Input shape should be given as 784 comma. If we are having an image of 30 by 30, then in order to handle that image, you should give 900 comma. If you are having an image of 50 by 50, in order to handle that image, you should give 2500 comma. Now, how many output neurons we are taking? 10, 0 to 10. Example, if I tell to you to do the hand digit classification task for your particular language, maybe it is Tamil, Malayali, or Kannada, or Telugu, or Marathi, or Bengali, then in that particular language, we may have example, we may have n number of letters. Example, we may have 20 letters. At that time, in the final layer, we should consider as 20 neurons. Now you can, now you are learning the technique in order to classify any handwritten digit, whether that is Japanese or French or Russian language or Chinese language, any language that is having a particular number of letters. Those letters you can take based on the number of letters, those many output neurons you can take in the final layer, then your project is ready. Okay. Activation function I am taking as sigmoid. As I mentioned previously, final layer, whenever we are using the final layer, at that time we can use either sigmoid if that classification problem I am taking, or softmax. Here I can take softmax also. But we should not use ReLU here because I have not taken any hidden layers. ReLU or tan-H are not allowed here. This is the activation function. What is the sigmoid in reality? Sigmoid is nothing but 1 by 1 plus e to the power minus z. What is this z? This z is nothing but our input multiplied with the weights. So this is output y. In order to get the output y, first we have to multiply x into w. After multiplying the x into w, we have to substitute that in z. Then we are introducing nonlinearity. Finally, whatever may be the x and w value, this value is range of 0 to 1. If you substitute infinite, then the value will be 1. If you substitute minus infinite, if you substitute minus infinite, then the value will be 0, because e to the power minus into minus infinity plus infinity, 1 by infinity 0. Now we are interested to compile. Means what actually we are doing? We are interested to measure the loss, whether it is properly calculated to or not. So we are giving an optimizer called Adam optimizer. We have many optimizers. What is an optimizer? We will discuss later, even in the deep learning course also. What is an Adam optimization? Andrew Ng discusses. As of now, optimizer is nothing but it is finding the optimum values of W and W2. Those are values we have taken. At what value of the minimum loss, if the value of the loss is minimum, exactly at that minimum loss value, we have to calculate the weights. So in order to calculate the minimum value of the loss, someone should be there to tell this is the minimum loss. That is what optimizer is doing. We are calculating the loss here, that is by using sparse categorical cross entropy. But someone should be there to tell this is the minimum loss. That task is being taken by this optimizer. Optimizer tells, stop here, this is the minimum loss. That is what the task of the optimizer. We have different losses. Mean square error loss we take for the regression problem, and Poisson loss, scale divergence, mean absolute error. You can try all these losses. When you try all these losses, you will find sparse categorical cross entropy for the classification problem. It gives the better accuracy. Now my model is ready. Just I have considered a single, that is the power of the Keras. That is the power of the TensorFlow. Now you are ready. Now you have built your network. You have taken your optimizer and you have considered your loss and you wanted to see the accuracy. Now you are training your network. In order to train the neural network, we have to use model.fit. When we are training, we have to train the extrained flattened. Means the flattened neurons we have considered, single dimension array we are taking, and a white train. We should not flatten white train. What is the requirement to flatten white train when it is a single values? And we are giving the epochs 10. Why? What is actually this epoch, and why we are giving 10 epochs? What actually this epoch is doing? In each epoch, example in first iteration, first iteration, or I can call it as a first epoch for your understand. First epoch. In the first epoch, we are giving the 60,000 images and we are training the neural network. And at the time of the training, what it is doing, it is calculating some W12 values. We have told na W7840. And we are not satisfied with these W1 values because the loss is not minimum. Who told the loss is not minimum? Optimizer is ready, tells loss is still not minimum. Then we will tell, okay, again train by using 60,000 images. Now, second time while training, what are getting updated? These W values are getting updated. This time still I am not satisfied because the error is still high. Compare it to previous time, the error is decreasing, accuracy is high. Accuracy high means it is capable of predicting more images properly. Like that, how many times we are training the same data set, then we call that many epochs we are considering. Each time the W values are getting updated. It is fine. We are taking the 60,000 images at a time, then it is called as batch. If we are using the gradient descent optimizer, then it is called as a batch gradient descent. If we are taking example 10,000 images at a time or 30,000 images at a time, then it is called as mini batch gradient descent, or you are take a short batch gradient descent. If you are taking only one image at a time, then it is called as stochastic gradient descent. Okay, this is the concept why we are taking epochs. You can even observe here, when we are training first time, the accuracy is 87% and the error is loss is 48, 0.48. So when we train for the second epoch, 0.91%, 91% accuracy, 91% accuracy, and the loss is 30%. It is decrementing the loss. When you are going to the 10th epoch, if I take more epochs, definitely I will get more accuracy. But the step interval, it is changing from 87 to 91 here. There onwards, it is changing very slowly. And then from here, it is almost constant, 0.9304, 0.9309. Even if I take more epochs, then only computationally it becomes burden to me. There is no further use to me. So I have stopped here, the 10 epochs. I'm executing here. See, this is how. Because I have taken low resolution images and 60,000 images, I have given only 10 epochs. It will not take much amount of time. These are called as metrics. Accuracy and loss, these are called as metrics. By using these two only, we will evaluate the performance. Fine, but we are not satisfied. 93% accuracy means we are expecting some more accuracy. Is there any way? Then I am telling, introduce a hidden layer. If we introduce the hidden layer, it is capable of handling the data. Okay, after training, we will check the test error and we will introduce the now the training is 93%, whatever the value training accuracy, and the loss is 25%. Testing time, the accuracy is 92% and the loss is 26%. Okay. If the training accuracy and the testing accuracy are near, then we call them the problem is not overfitting. If training accuracy is some 95%, testing accuracy is 40%, means training error is minimum, but testing error is very high. At that time, we can consider it is well trained, but the trained images, it has memorized. Then we will call it as it fails at the testing. Then we will call it is facing a problem of overfitting. Okay, we have discussed until the testing accuracy. And then we want to see the output. So we are giving a new variable y predicted. So y predicted is equal to model.predict. Model.predict, model is a variable as we have considered. Model.predict x test flattened means it is taking the test flattened data. Test flattened data is nothing but the 28 by 28 images we have taken into a single array, 784 values, and we are predicting what are the original values for this. Okay, the original values, the predicted values for this. Okay, predicted values, original value is the image we will see. The predicted value, what are the predicted values for this? The predicted values are given. Example, for the first image, these are the predicted values. But for first image, I told one value should be output. Yes, one value should be output. But this array is giving the values of 10 neurons, all neurons. Out of these neurons, this is the value for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now see which value is higher. You can observe the value 6.6 into 10 to the power minus 1. This value is higher, means it is 0.66. Compared to all other values, this is higher. You do not see this 6.7 is higher, but 6.7 into 10 to the power minus 3. You consider that also. Okay, out of all these values, this value is higher. This is indicating 7, but still I am not satisfied. I wanted to see with the matplotlib. Okay, so plot dot mat show of the x test of 0, it is indicating 7. Similarly, I can take some other value, example some 100 101 image. What is predicted value? This is the predicted value. Now without seeing matplot that image, I can now tell what is the value. This is 0 1, okay, which is having very small value. This is having very small value. So 0 1 2 3 4 5 6. So this value is 6. You can now see whether the value is 6 or not. So x test of 100. Yes, our model is predicting well. Like that, I can take the 59,999. Model predicted 59. Sorry, testing images we have considered only 10,000. Okay. So 9,999. 9,999. So this time the value, again it is minimum at 1 2 3 4 5 6 7. So this value is 7. Now we will check. So x test value of 9,999. It is showing 6. This is what we call as an error. The accuracy which is giving 94%, some error is there. Now this is an example for an error. We have got correctly the required thing. See here, it is showing this 1 0 1 2 3 4 5 6. Sorry, I have calculated from 1. It is 0 actually. 0 1 2 3 4 5 6. Okay, it is 6 only. Correctly it has predicted. So the value of this is we are printing, then this is 6. Okay, so this is how we have taken a single layer. Means we can consider the input layer and output layer are 2 layers. In that case, it is 2-layer neural network, and we have trained our network to predict the handwritten digit in the image, and based on that, when we have given the 10,000 test images, it is predicting. Okay, later I am changing this value to again to 0. So we have taken the y predicted values. So 7 2 1 0 4, these are the first 10 predicted values. I can see the first 5 predicted values. These are the first 10 predicted values. Similarly, these are the first 100 predicted values. If I want some 5 to 10, then also 5 to 10, just for checking. These are the 5 to 10 predicted values. So again, I am switching to first 5. These are the first 5 predicted values. Okay. Finally, I am interested in some function I have used here, np.argmax. If you are interested to know this, it is nothing but for that particular value, whatever may be the highest value in the final layer. Example, we have taken 10 neurons. Out of those 10 neurons, whichever is having the high value, we are fixing to that value. Example, for the first predicted output, the neuron 7 is giving the highest output, so it predicted as 7. NP argmax means it will take the maximum value. It is actually working with the numpy. So we have imported numpy as we discussed previously. Now 2 means NP argmax for that particular second neuron. 2 means actually it is third neuron, 7 means 8th neuron. Okay, because we are starting from 0. 2 means the third neuron is giving the highest value. Similarly, 0 means first neuron is giving the highest value for that particular image. So it is predicted as 0. Now we have to draw the confusion matrix. We are taking a TensorFlow SDF. So we have taken the confusion matrix. What is this confusion matrix? I will explain. See, it is like I think with the image it is easy to explain. With the image I am explaining. This is number of truth, means the truth is on the y-axis and the predicted is on the x-axis. You can think in this manner. 954 times it is predicted as 0. That is correct zeros predicted as correct, means the predicted 954 values predicted as zeros, and truth also 954. For those 954 values it is fine. I am taking some other values. Example, this 4, see here. 4 times originally the value is 2, truth value is 2, but it is predicted as 0, means 4 false values. And originally the value 3, handwritten digit 3, 2 times it is classified as 0. Like that, this is called as confusion matrix. Where is the highest value? You can see here. Based on that, okay, this is the highest value. Means where the error is coming, majority of times it is in the 2, it is considering as 8. Why it is happening? Majority of us, we may write example like this. It will consider that as an 8. So false cases are coming, majority cases, sometimes some persons may write like this. So by taking this into consideration, false cases are being considered with the 2 and 8 because those two letters are similar. And where is the next highest value? We can check here. 27, 44. 44, what is that? 3 is considered as 5. Means again, whenever we are taking that 3, it is sometime it is considering these two are like similar. That's why the true it is predicting as 5. This is what we call as confusion matrix, because it is confusing with the existing truth values. We are checking with the predicted values and we are telling the diagonal elements in this confusion matrix is giving the original values. These are the truth values. Remaining, except the diagonal, whatever the remaining values here, they are indicating originally some value, but it is predicted as another value. As of now, we have discussed how to detect the handwritten digit from a given image by using a neural network without any layer. Next, we will discuss if we take a single layer and if we incorporate a layer, if we incorporate a hidden layer, incorporating hidden layer, what advantage it gives and how accuracy improves. We will discuss about that. Now we are taking a hidden layer. In order to use the hidden layer, see, previously we used first line is same. We are not changing the first line. Input shape 784 comma. We are taking second layer. How many neurons should be there in the second layer? 100 neurons I am taking. You can change this number also. That's why first I am giving the output. Output 100 neurons. You can change this number. You can take 200 neurons or 300 neurons. But the input is fixed 784, and activation this time I am using ReLU for the second layer. Okay, and final layer, the neurons are 10 fixed because we have to classify 0 to 9, and the activation function for the final layer is sigmoid. I have introduced one layer. Now after that I am using optimizer Adam, loss sparse categorical crash entropy, matrix accuracy. Now epochs 10, all these are known to you. Now I am executing this. This is with 2 layers. It is being executed. Definitely it will give high accuracy, but only thing is it will give an additional advantage, additional burden to the computer. The time for execution will become more. Now if I am interested to take the 2 layers. In that case, in the first layer I am taking the 784 neurons as input. In the second layer I am taking 100 neurons. In the third layer I am taking 50 neurons. Now with the 2 layers it will give more accuracy compared to the 1 layer. Like that you can include n number of layers, 5 layers, 6 layers. That is the power of the Keras. With a single line you can include a layer. Now I am executing. Now see, the accuracy is 99% because we have introduced a single layer. The accuracy is 99%. It is, and the loss we are getting is only 2% with the single layer. Now I have introduced 2 layers. This time it will give much more performance compared to the previous one. But we are getting 99% accuracy here because this is a simple handwritten digit classification. If we are taking any human image, if we want to tell who is there in that image, if we want to classify at that time, this simple neural network may fail. But as of now, whatever basics you have learned, the same concepts will be applied even for the complex problem also. That's why we have made our base is very strong. We are going to implement these basics in coming complicated projects. Now, previously see, the accuracy is 99.18%. Now the accuracy is 99.21%. This indicates that there is only a small portion of change. Even if we improve number of layers from here onwards, there is no much change in the accuracy. There is no much change. That's why we have satisfied with the 2 layers. We have stopped here. If you want, you can increase the number of layers also. And then we are calculating the test error. This test error is 97%. And confusion matrix. Now see the confusion matrix. Previously, all 2s are classified as 8. That problem is gone because of taking 2 more layers. We have considered 2 more layers. Now more error is there at a particular point, at this particular point. 7 is being considered as a 9. This is the original 7. This is 9. So this 7 is being considered as 9. This is the error where we are getting. What we are actually doing for the implementation of the confusion matrix, this point we have not discussed. We are taking the, as we have already discussed, TF TensorFlow math.confusion matrix. We are taking the truth values on the y-axis and the predicted values on the x-axis. So y test are the true values and the predicted values are given to the x-axis, and based on that we are plotting by using the matplotlib. And finally, last one point we have to discuss. We have previously mentioned that we have taken a 28 by 28 image, and then we have flattened that image, and then we have given to the neural network. But now a new layer is introduced in the Keras, that is flattened layer. If we use this flattened layer, simply if I write keras.layers.flatten, there is no need to reshape the 2-dimensional array into single-dimensional array. Simply it will convert the 2-dimensional into single-dimensional array with the keras.layers.flatten. It is flattening the 28 by 28, the 2-dimensional array into a single-dimensional array. Now remaining by using this flattened layer, if I am training, now also I am getting a very good testing accuracy, 97.47. Because of the time constraint, we are taking only 5 epochs. See, because of because I have taken 5 epochs, it is 98%. Previously, for epochs 5, at epoch 5, it is 98.12. Now at epoch 5, 98.18. So flattening layer, introduction of flattening layer is giving higher accuracy compared to direct. When we are taking that array, it is we are doing some more coding. Instead of that, we can use the flatten layer. We can give a 28 by 28 image and we can directly flatten it. Finally, our testing accuracy is 97% and error is 8%. Okay, now finally we are discussing in a brief what we have done. We have considered a 28 by 28 image. How many such images we have considered? 60,000 images for training, 10,000 images for testing. Each image we are considering as a pixels, 28 by 28 pixels, and we have flattened. Now we have learned just now flatten layer. By using the Keras flatten layer concept, we have flattened that, and we have first we have learned without hidden layer and with hidden layer and incrementing of the number of hidden layers. We have learned what is TensorFlow, what is Keras, and we have used NumPy and Matplotlib. Now you are ready to predict. Now your neural network is ready. Your neural network is ready to predict any given handwritten digit. If you give that any image to that neural network, it will predict.